Today, we're talking about the hidden hazards of hand sanitizer. Yeah, that little bottle you probably have in your car or your bag right now. But is it as harmless as we all think it is? All right, let me ask you something right off the bat. What do you think is the most overlooked fire hazard in your car or even your house? Just take a second to think about it. Something you see and use every single day.
Believe it or not, it might just be your hand sanitizer. I know, that sounds totally backwards, right? A product that's all about safety being a danger, but stick with me because once we get into the science, you'll see how it all adds up.
So, yeah, we're diving into this hidden fire hazard. Let's really break down why this thing we use for safety can be, well, not so safe. And it all comes down to what's actually in it. So to really get this, we've got to look at the science of flammability. What's inside that little bottle that makes it burn? Let's take a look. Okay, so if you look at the ingredients, you'll see stuff like water, glycerin, maybe some fragrance. But the main event, the active ingredient, is almost always alcohol. Either ethyl alcohol, ethanol, or isopropyl alcohol. And that is what we need to focus on. And we're not talking a tiny bit of alcohol either. For these things to actually work, they have to be packed with it. We're looking at a concentration of 60 to 80%. That is a huge amount, and it's exactly why this stuff is so flammable.
Okay, so why is alcohol flammable in the first place? Well, it boils down to a few key things. It has a low boiling point, something called high vapor pressure, and its molecules don't cling together very tightly. Now, what does all that sciencey talk mean? Simple. It means alcohol turns into a gas, or evaporates, super fast.
Let's zoom in on that term for a sec. Vapor pressure. It sounds complicated, but it's not. It's just a way of measuring how much a liquid wants to evaporate. In alcohol, it really wants to evaporate. It has a super high vapor pressure, meaning the second it hits the air, poof, it's turning into an invisible gas. And that right there, that's the real danger. It's not really the wet gel on your skin. The real risk is that invisible, flammable cloud of vapor that forms around your hands almost immediately.
Okay, so we've established the villain here is the invisible vapor. Now, let's connect the dots. How do you get from liquid to flame? What's the chain reaction that leads to ignition?
It's actually a pretty straightforward process, just 4 steps. 1, you put the sanitizer on. 2, the alcohol starts to evaporate right away. 3, that invisible vapor cloud we talked about forms. And then, step 4, if that cloud touches an ignition source, we're talking a spark, a flame, anything hot, boom, it ignites. This is probably the most crucial thing to remember from all of this. I'm going to say it again because it's that important. The liquid itself doesn't burn first, the vapors burn. If you get that, you get the whole picture. And for all you science buffs out there, here's the quick chemistry lesson. That alcohol vapor mixes with oxygen, right? Well, when you add a spark, you kick off a combustion reaction. And what does that release? A whole lot of heat and light. In other words, fire. All right, enough with the theory. We get the science. Now let's talk about where this stuff actually matters. What are the real-world danger zones where common sense has to meet chemistry? So think about it. When could this actually happen? How about using sanitizer and then immediately leaning over to light birthday candles? Or using it while you're cooking over a gas stove? What about lighting up a smoke right after you've sanitized? Even just using it in a small, closed-off space, like a car, can let those vapors build up, making any little spark way more of a threat. Okay, so right about now, you're probably thinking, hang on, there's water in it too, right? Shouldn't the water just put the fire out? And you know what? That's a totally fair question. But the chemistry is a little bit sneaky here. And here's why that doesn't work. The alcohol is basically in a race with the water to evaporate, and the alcohol wins every single time. It evaporates so much faster that it's already formed that dangerous vapor cloud long before the water has a chance to do anything. The water just can't keep up. Okay, so we've talked a lot about the danger, but this isn't about making you afraid to use hand sanitizer. Not at all. It's about being smart. So let's talk about the most important part, how to stay safe. Here's your safety checklist, and it's pretty simple. Number 1, and this is the big one, always let your hands dry completely before you go near any flame or heat source. Just give those vapors a chance to drift away. And it goes without saying, keep the bottle itself away from sparks and flames. And maybe don't use it right when you're flipping burgers on the grill, So really, hand sanitizer is like 2 sides of the same coin. If you misuse it, yeah, it's a fire hazard. But if you use it properly, it's exactly what it's supposed to be, a great tool for staying clean and safe. Ultimately, it's safe when it's used the right way and dangerous only when it's misused. The power isn't in the bottle, it's in how you use it. So next time you squirt some sanitizer into your palm, just remember the invisible science happening right there. And it kind of makes you wonder, right? What other everyday things in our homes have these hidden scientific risks? Think about it. Aerosol cans, cleaning supplies, the list goes on. There's a whole world of chemistry right under our noses. So as always, stay curious.